Today we're going to be talking about lesson 9.2 on lines of best fit. So a line of fit is a line drawn on a scatter plot close to most of the data points. So a line of fit. It can be used to estimate data on the graph. So we can use this to make predictions or estimations on what might happen on a different point on the graph. So if we look at the first example here, it says the table shows the numbers of people who have attended a festival over an 8-year period. Make a scatter plot of the data and draw a line of fit. We're going to then write an equation for that line and interpret the slope and the y-intercept of the line of fit and predict the number of people who will attend the festival in year 10. So there's several parts of this question. The first part asks us to make a scatter plot. So we need to use what we learned in lesson 1 to make that scatter plot. So here I see that my data goes from about 400 to 2400. So I have decided that I can count by 200s all the way up my y-axis on my graph. So again, I'm not going to label every single one. I'm going to count though by 200s and label every other one. So go ahead and label your y-axis now. On my x-axis, I see that we're counting by ones, 1 through 8. So I'm going to label down here 1, 2, 3, 4, 5, 6, 7, 8, and then we'll go ahead with 9. So this is the x-axis is for years, and the y-axis is for attendance. Now, just like in lesson 1, we're going to plot these points on this scatter plot. So go ahead and do that now. Okay, now in order to draw the line of fit, you need to use a ruler or a ruler tool to draw a straight line. Now, the rule of a line of fit is that it should split the data evenly. So what this means is that about half the data should be above the line and about half the data should be below. So with that being said, here we have 8 data points. So half of that would be 4. So we want approximately 4 points above the line and 4 points below the line. Now, when we're talking about 8 data points, it's pretty easy to split that in half and figure out that 4 should be on one side and 4 should be on the other. It's not always going to be exactly even. If we have 200 pieces of data, we might have 102 on one side and 98 on the other, and that's okay. It's not going to always be exactly even, but it should be close. So again, using a ruler to draw a line of fit through the center of the data. So again, straight line. Now I don't have a ruler tool, unfortunately, and I don't also have a straight line tool, but I'm kind of going to show you here. So if I would go up here, I can see that that does not split my data. If I go down here, I can see that that also does not split my data. So I kind of need to find that happy medium. Now this is not going to be exact science here, but I can try to get my data split kind of evenly there. Now, again, this is not a straight line, and I know that, but we're doing the best we can here. So you can see that I have 4 on one side and 4 on the other. Remember, splitting that data in half. Now, writing an equation for the line of fit. Now, you've talked about this probably a little bit before. So equation format for a line is y equals mx plus b. So with this equation of y equals mx plus b, the m stands for the slope, and the b is the y-intercept, where it crosses the y-axis. So if we are writing the equation of this line, so this is part B of the question, we can find that the slope is where the point is on the 1. So here is about 270. So I can say y is 270x Now, where's the y-intercept? Where does it cross the y-axis? Well, it crosses here, which is 0. So I don't need to put plus 0 on here. So my equation for my line is y equals 270x. Now, interpret the slope and y-intercept. So explain what that means. So for part C, the slope of 270 means that there are, in context of this problem, 270 people in attendance per year. 270 attendance per year. We get that from the labels here, the attendance of 270 for each year. The y-intercept of 0 tells us that at year 0, there is 0 people in attendance. So y-intercept of 0 is 0 people in attendance that year. Now for part D, predict the number of people that will attend the festival in year 10. So we are using this equation here, y equals 270x. Now, where does 10 go? Well, 10 is years. That's the the x-axis. So we put 10 in for x. So 270 times 10, remember when there's no operation, we're multiplying, is 2,700. So in year 10, we can predict that there would be 2,700 people in attendance. And this is how we can use that line of best fit to make our predictions.